Okay, good morning, Professor David J. De Los Reyes. Okay, my topic for this session will be a long video format on college algebra. We are doing good on college algebra. Okay, let's proceed. My topic for this morning will be college algebra lesson number 17. And the title of the topic will be Solution of System of Linear Equations Using Determinants. Okay, the method of solution is by using determinants or the so-called Kramer's rule. Okay, we will not go very far on this determinant solution because for equations that involves for unknowns and up, okay, it will be a very long solution. But actually, the worst case scenario for linear equations will be maybe a four linear equations involving four unknowns. But if I have got the choice to bring out the solution, I don't go with the determinant solution because it's a long-term solution, long-form solution. I might go with the solution by using elimination or substitution. But since we are discussing the concepts of Kramer's rule, we will try to bring out the concept on how to solve a linear equation using the determinants or Kramer's rule. Okay, we are given to simplify the concept on how we explain the concept of determinants. We will just let for the meantime system of linear equations involving only two unknowns for the meantime. Because if we go to the third three unknowns, that will be a different story. I mean, the variation how to bring out the determinant is a different thing. Even on the four unknowns, it's a different thing. It's more complicated. But so we could visualize how determinants work. I will be giving two system of linear equations only in two unknowns. Okay. So if we are given a1x plus b1y equal to c1, that will be equation number 1. Okay. So two unknowns, right? Okay. And the second equation will be a to x plus b to y equal to c2. That will be equation number 2. Or just to simplify the concept of determinants, okay. The solution form will be something like this, okay. I will not bring out the derivation how it came out like this. We could do it, but it's a little bit complicated, so I will just give you the summary. For two unknowns involving two equations, the value of x will be d sub x over d, and d should be equal to. I will tell later on how it came out like this, okay? It will be c1, c2, b1, b2. We call this as a matrix, right? If we write in this form, we call it matrix. Okay? All over a1, a2 over b1, b2. So this is another matrix. Right? So meaning to say, to compute for the value of x, we must have to evaluate the first matrix and the second matrix. And to evaluate the matrix on the numerator, it will be something like this. Okay. This is standard for two equations, two unknowns, three equations, three unknowns, four equations, three unknowns. Okay. How we simplify the matrix. Okay. But for two unknowns, it is much simpler because for three unknowns, there will be 6 inside. For four unknowns, there will be 8 inside. So actually, it's a more complicated thing. Right? That's why I want it to simply bring out the concept the simplest way, okay? So I will give only two unknowns for the meantime. To simplify this matrix on the numerator, it will be something like this. You try to multiply this, the numerator first. We'll go downward like this. You try to multiply this one. So it will be C1B2. Okay? Then you try to subtract this one. Those that are going up, you subtract it. So this is minus. The operation is minus. The product of C2B1. Okay? The one going down is a plus, right? So it is actually C1B2. There should be a plus over here. I didn't put it. So C1B2 minus C2B1. Minus C2B1. That's how we simplify the matrix on the numerator. For the matrix on the denominator, it will be something like this. It's the same procedure. You go downward, take the product, A1, B2. So this one will be A1, B2. Then try to subtract those going up. This is A2, B1 minus A2, B1. Okay? Going down is plus, minus going up. Going down is plus, going up, this is minus. So this is both minus. Going up, this is going down, going down. Okay, that's how we simplify the matrix on both the numerator and denominator. But I am telling you, on the equations that involves 3 unknowns, there will be 6 elements inside. So it's a more complicated thing on how to simplify. That's why I don't recommend solution for solving linear equations in more than 3 unknowns by using determinants. Okay, you will go crazy. Okay? But at least we know how determinants or Cramer's rule work. Okay, for the value of y, it will be determinant of y all over d. Okay? Oh, I forgot something. If we are solving for x, how we place the elements inside it will be, you start with this, C1, B1, then C2, B1, okay? If you are solving for y, it will be a different one, okay? It will be A1, C1, that's A1, C1, that's A2, C2. You got it? If you are solving for y, cover the y, so the element that goes inside the matrix will be A1, C1, and this will be A2, C2. And for D, it will still be the same. You just cover the pure constant. It will be A1, B1, A1, B1, this is A2, B2. Even on the value of x, for the value of D, it's the same. Just cover the pure constant, it will be A1, B1, this is A2, B2. Okay, so you now know how you arrange this one. Because in 3 equations, 3 unknowns, how we arrange the elements inside will be a different one, okay? That's why I'm telling you I don't recommend this solution here. It's more complicated, okay? Okay, let's try to simplify the value of y using d, the determinant of y over d. If we are solving for y, the elements that goes inside will be, you cover this one, it will be A1, C1, and this is A2, B2. So if we try to simplify this one, this is A1, right? Take the product of this. So that's A1, C2, minus the one that goes up, minus. The operation is minus. The product A2, C1. For the bottom portion is the same as the first one. It will be the product A1, B2, A1, B2, going down is plus, minus the value of the one going up, minus A2, B1. This is minus A2, B1. Okay? These elements are actually all constants. So we are just using the coefficient of the given system of linear equations. Okay? Okay, let's try to bring out an example problem so we could visualize how a Cramer's rule works and how to compute for the unknowns. Solve using Cramer's rule or determinants. The given two equations are actually x minus y is equal to 2 and 2x plus 3y is equal to negative 1. That will be equation number 1 and this will be equation number 2. Actually, if we use the previous solutions, elimination by addition or subtraction, we could do this. Okay? If we try to use the elimination by substitution, we could also solve these two equations here. But for tonight, or for this morning, our solution will be by using determinants. Okay? So if we try to bring out the solution, we'll follow this. Okay? For dx, okay, for dx, we are solving for x, right? So we cover y. So the elements that goes inside will be 2 and minus 1. Okay? We are solving for x, right? We are solving for x. Then it will be negative 1 and plus 3. Because we are solving for x, right? So dx will be, if we try to simplify this, so you now know how we arrange the elements inside, right? If we are solving for x, cover x, right? So it will be 2 and minus 1, then negative 1 and 2 and minus 1 and negative 1 and 3. Negative 1 and 3. The coefficient of y here is negative 1. This is negative 1 and 3. So if we try to simplify this, it will be the product of this. 2 times 3 minus the value going up. Minus, the operation is minus. Okay, but be careful with the sign of the elements inside. This is negative 1, so I place a quantity negative 1 times a negative 1. Okay, then use your knowledge on fundamental operations and how to simplify, right? That's why in the study of college algebra, we started with fundamental operations. So this will now be 6, 2 times 3 is 6. A minus 1 times a minus 1 will be a plus 1, right? But this is preceded by negative sign. So it will become minus 1. So minus 1. So 6 minus 1 will be 5. So dx will be 5. The determinant for the value of x will be 5. Okay, let's try to compute for the determinant of y. Cover y, right? Okay. So the element that goes for the determinant of y will be the coefficient of this column here. It is 1 and 2. This is 1 and 2. Okay? Next one will be the one, the pure constant, it will be 2 and minus 1. This is 2 and minus 1. Okay? That's how we got the arrangement inside. If we are solving for the determinant of y, cover y, so just take the coefficient of x, then the pure constant. And if we try to simplify this, it will be the product of this. 1 times minus 1 minus the one that goes up. Minus, the operation is minus. But take note of this side. This is plus 2 and this is plus 2. So there's no problem. This is times plus 2. This is times quantity plus 2. Then try to simplify using your knowledge of fundamental operations. A 1 times minus 1 will be minus 1. A plus and a plus will still be plus, but this is preceded by minus, so it will now be a minus 4. Minus 1 minus 4, we're combining two negative terms, it will be negative 5. Right? Okay, let's try to compute for the determinant of the two given linear equations. The determinant is just cover this one, then take the coefficient of the left hand side. So it will just be simply 1 and 2. 1, 2. Then it's negative 1 and 3. Negative 1 and 3. That's how we got the elements that goes with the matrix of D. Okay? Then if we try to simplify this one, it will be this product here. So 1 times 3. Take note of this side, right? This is plus, so there's no problem over here. Minus, the operation is minus. Once we go up, the operation is minus. But take note of this side. This is plus 2. And this is negative 1. That's why I place a quantity over here. Okay? If you are lazy placing the quantity sign, you're in danger. Okay? So don't forget the quantity on the signs of grouping and the fundamental operations. So if we try to simplify this one, 1 times 3 is 3. Okay? A plus and a minus will be a minus, right? But this is preceded by minus. So a minus times a minus, this will now be plus. This plus 2. So 3 plus 2 will be 2. Okay? So if we go back now to this equation here, and this, because we computed the value of dx, d sub x, and d sub y, and d separately, it is just a matter of substitution now. So x now will be the determinant of x over the determinant d. The determinant of x is actually 5. So this is 5. And the determinant d is actually 5. This is 5. So 5 over 5, a plus and a plus will still be plus. So the value of x is plus 1. Okay? Using the second equation, the value of y will be the determinant of y over the determinant d. And this should be, dy is actually negative 5. And the determinant d is plus 5. A minus and a plus will be a minus, right? So the answer will be negative 1. So the solution for the two given linear equations using determinants or Cramer's rule is that the value of x is equal to 1 and the value of y is equal to negative 1. To check the validity of our answer, you could use elimination by addition or subtraction, or you could use solution by substitution, or it is just a matter of using the given equations, substitute the values. So using equation number 2, 2 times x will be 2 times 1, the value of x is 1, right? Plus 3, I'm following this, times the value of y, which is negative 1. Is it equal to negative 1? The right hand side is negative 1. Will it be true that the summation of the left hand side after the simplification will be negative 1? If we try to simplify, 2 times 1 will be 2, 3 times minus 1 will be a negative 3, a plus and a minus will be minus. Is it equal to negative 1? 2 minus 3 is minus 1. So minus 1 is equal to minus 1, it is true. So our answer by using the Cramer's rule or the determinants rule is actually x is equal to 1 and y is equal to negative 1. Okay, that's it guys. How we solve a system of linear equations, okay, using Cramer's rule or determinants rule. But for this equation here, this only applies for 2 unknowns. For 3 unknowns, that will be a different story. It's more complicated. For 4 unknowns, it's much more complicated. That's why I don't recommend the solution, determinants in the solution of a system of linear equations. If the number of unknowns is actually more than 3, okay, it's up to you if you use determinants. Okay, that's it guys. So for those of you who are taking up college algebra, this is for you guys. If you want to subscribe to my channel is at youtube.com/@ProfDavidJ. If you want to share it, please click share. Okay, good morning from Los Angeles. Thank you.